Why Python built-in all function returns true for empty iterables? I know it has a good reason, but I want to know what reason. If all is intended to check if every item on iterable evaluates to true, and we know empty lists are evaluated to false. So why the all returns true for empty lists? Less than edit greater than. I already read the docs, and I know the implementation. But the question is, why not? There is a logic on this. If you have a list of done tasks, okay, on the above hypothetical example it really makes sense, if I have no tasks, so I can go home. But there are other cases and I don't think all was made for to-do lists. LOL. Less than / edit greater than.
This is expressed as for all x in S, x is true. If S is empty, there are no x. However, the truth statement remains true, because for all x, x was true. There just aren't any x. Here's an explanation using logic. Consider two sets A and B where A plus B is the union of the two sets. If any A plus B equals true, any A or any B equals true, but we cannot assert either any A equals true or any B equals true. If any A plus B equals false, any A equals false and any B equals false. If all A plus B equals true, all A equals true and all B equals true. If all A plus B equals false, all A equals false or all B equals false, but we cannot assert either all A equals false or all B equals false. Now instead of B, let's add the empty set O to A. We want to come up logic such that adding the empty set does not change the values of all or any, since A plus O equals A. Any A plus O equals any A or any O. Any O must be false, so that if any A is true, any A plus O is true, and then if any A is false, any A plus O is false. All A plus O equals all A and all O. If all A is true, all A plus O is true. Therefore, all O is true.
All, documented to return true if all elements of the iterable are true, or if the iterable is empty, is equivalent to the following. Since there are no elements, it will skip the loop and return true.
Suppose all is false. Then, for all non-empty list A, all A plus should be also false as. Since A plus equals A, we know. But all could be true, for example, A equals true. Hence, for all non-empty list A, all A plus should be also false. This contradicts. As a result, the first assumption is wrong and all is true.
This comes from the mathematical logic. Everything is true of the elements of the empty set, this URL. See also this URL.
So, this is the first